Alright, I'm going to walk through a linear programming process, so this will probably be a longer video, so feel free to, pause and think about this, or fast forward through things that you definitely know. But anyway, the problem says your class plans to raise money by selling t-shirts and caps. The plan is to buy t-shirts for $8 and sell them for $12, and to buy the caps for $4 and sell them for $7. The planning committee estimates that you will not sell more than 120 items. Your class can afford to spend as much as $800 to buy the articles, and you want to maximize your profit. So there are really 8 steps when it's all said and done to a linear programming process. The project that you're taking home, the examples that you watched earlier breaks that down into all the steps, but of course the first thing you want to do is define your variables. So what can vary? Well, the number of t-shirts and caps that you sell. Everything else in that problem, if you read it, is fixed. So I'm going to use, it doesn't really matter, but I'm going to use T and C for t-shirts and caps. So T is the number of t-shirts, and C will be the number of caps. Other things that you might want to define, of course, you want to maximize profit, so I'll say P is profit. Then your objective quantity. So your objective quantity, of course, is what you want to maximize or minimize, and it's pretty clear here what you want to maximize. It's your profit. So my objective quantity is going to be P for profit, which I've defined, and then you have to think about what is your profit going to be here. So if you buy t-shirts for $8 and sell them for $12, you're going to make a $4 profit, right? Because you spent $8, sold them for $12, so you just made $4 on t-shirts. So my profit is going to be 4T. Same idea for the caps. You're going to buy them for $4, sell them for $7, so you're making a $3 profit. So that's going to be plus 3C. So that's your objective quantity to maximize your profit. That's the first 2 steps, really. Next, we go into the constraints, and really I get the objective quantity out of the way because that's what you want to maximize or minimize, and sometimes people accidentally think that's a constraint. So figure out what you want to maximize, minimize, get that out of the way. Okay, right, so in fact I'm going to, well, there's nothing to cross out because I had to do a little math, but my constraints are things that, I can't go past, or I have to, sell this many and all that good stuff. So let's see here, where is a constraint? Well, they estimate that you cannot sell more than 120 items. So remember, my variables are t-shirts and caps, right? So altogether, the number of t-shirts and caps can't exceed 120. So number of t-shirts plus the number of caps has to be less than 120 total. Your class can afford to spend as much as $800 to buy the articles. So money, and I know that I can buy t-shirts for $8, and I can buy caps for $4. Okay, this has nothing to do with profit, right? And I can only spend as much as $800. So $8 per t-shirt plus $4 per cap has to be less than or equal to $800 because I can't exceed that amount of money. The implied constraints are the easy ones to forget, so do your best. You know that you can't sell negative items, so the t-shirts have to be greater than or equal to 0, as do the caps, which really just puts you in the first quadrant. And those are your constraints. Alright, the third and fourth steps would be to graph and then find and verify non-axis vertices. So I have already graphed it just to save a little bit of time, but I want to make sure that you understand. I use the variables C and T for caps and t-shirts. It doesn't matter which one you consider Y. So if I said that T is my y-axis. If you said C was your y-axis, then your graph would look different, but we would definitely have the same outcome. Okay, so please understand that that does not matter. But I did say that T was my y-axis, so it's like I solved these both for T. So on this one I subtracted C And on this one, I'll kind of come down here. Well, now you can handle this math. So to solve for t, I first subtracted 4 and then divided by 8, so that would be negative 1/2. And then 800 divided by 8 is 100. So I looked at my y-intercepts and I said, well, I got y-intercepts at 100 and 120, so clearly not going to scale by 1s. 20s would be great. That would hit them both perfectly, so that's why I decided on scaling by 20s. And I was consistent just so that I could plot my slope as if it were, you know, scaled by 1s. So this one started at 120, which you can see is right here, and then had a slope of negative 1. So I went down 20 over 20, down 20 over 20, etc., etc., and you can see that line. This one started, had a y-intercept of, or t-intercept of 100, and a slope of negative 1/2. So I went down 20 over 40, down 20 over 40, etc., etc., and you can see that line. Both of them were shaded less than or equal to, so the intersection would be just where they're both less than. Okay, now the finding and verifying non-axis vertices, well, and all vertices really, but I'm going to highlight the vertices of the shaded region here, 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 and here. Now, I think that it's probably clear that axis vertices are 0, 0, like that's a duh, the origin. And then this one here is pretty clear that that's at 100. So that's at 0, 100. And the other one that's very obvious because it's right on the axis is this one. So 20, 40, 60, 80, 100, and 120. So that is at 120, comma 0. The only one in this definitely is obvious what the intersection is, but it's not on an axis. So even if it's clear to you because you did such a nice graph, you have to verify those non-axes. So it's where did these two lines intersect. So I'm just going to do a quick elimination here. Okay, I'm going to eliminate, doesn't matter, I guess, C. So I'm going to multiply this one by negative 4. Okay, so I'm going to have, I'll use a different color here, negative 4c minus 4t is equal to negative 480. The second equation I don't need to change. And notice I dropped the inequalities just to solve. My c's eliminate. I have 4t equals 320, and that means that t is going to equal 80. So if I know t is 80, going back up to this equation, I can see that c would have to make that work out, that that intersection point, if that were an equal sign, would be 40. So I could already see that this point is at 40, 80 right there, but I just verified it. So my last vertice is at 40, 80. Okay, last step is finding the maximum profit using our objective quantities. So I already defined my profit function, I found my vertices, and I left off the origin. I think it's obvious that that's not going to maximize, but it's still part of the constraint system, or the feasible region. So I'm going to plug in 40 for C and 80 for T, and I'm going to do this for every point. So 120, 0, and 0, 100, and of course 0, 0, which is obviously not going to maximize our profit, and that's nothing. And this is going to be 400, this is 360, these are all dollars, right? And this one is $440. So this is the maximum profit. So to make $440, you must sell 40 caps and 80 t-shirts. So you need to make sure you interpret what that answer is.